Hello, class. Welcome to 6510 Global Operations and Supply Chain Management. I wanted to take the time to introduce myself and talk to you about this course. So I'm going to get started. So let me take the time to introduce myself first. My name is Samantha Gibson. I am an assistant professor here at Robert Morris University. And previous to Robert Morris, I worked for Northern Illinois University up in DeKalb near Chicago, Illinois for about 11 years. And prior to that, I worked 20 years in industry. So I worked for BP and I worked for PepsiCo, which was a division of PepsiCo called Frito-Lay, and I worked for 7-Eleven. So lots of experience with supply chain, wholesale distribution. And I'm happy to share that with you in this course. And hopefully, after this particular lecture, you'll learn a little bit about gasoline. So that's my background. But I want to talk to you also about my expectations in the course. And so, like you, as I said, I worked for Northern and embarked on my doctorate. So I was doing full-time school, full-time work. It was quite taxing. So I understand the pressures that go on in achieving your MBA. I didn't do asynchronous MBA. I actually went to evening school when I was, I started at the University of Pittsburgh and I finished at Northern, Illinois University. So I get it. So in essence, time is of essence. Lots of pressures, job demands, and it can be taxing. So with this course though, one of the lenses that I want you to kind of think about is from a strategic lens, up here, not down here, over above, not in the weeds. I'm thinking about supply chains. And when you think about those things, I think it'll help you. And, 2 to 4 hours a week set aside time so that you have the ability to go through the modules and really think of it from a strategic level, because that type of thought process will help you get through this course. And of course, it's my job to help you get through the course. So if you have anything that you need, you send me an email and we'll work on getting things to help you with whatever you're looking for. So let me end my introduction and then go into some things about the gasoline supply chain. So nowadays, everybody is all offering the price of gasoline is tremendously high. People are saying that the oil companies are making a lot of money. Well, that's not really the case. As with everything, it's all supply chain and economics. And the higher the gasoline price, sure, the higher the margin, but the higher the cost it is to produce and bring it to the customer. And let me say that again. The higher the price, the higher cost it is to produce, and the higher the cost it is to bring it to the customer. So as you think through these things, I want you to think about some of the things that have happened globally. Okay, so I'm going to take my little pointer here and say, the first step is the upstream. And this upstream here is where they get the oil and gas. They pump it out of the ground. And what has happened here is that we have let me get my pointer here. I don't like that color, so let's do this. We have a war. Oh, that's bad. But you get what I'm saying. We have a war going on. And in Russia, BP and Exxon, I know for sure, got their supply, a lot of it, from Russia. So in essence, they're choked. And then that has rippling effects down the supply chain. So when you go down to midstream, where process and storage and transfer, the cost of gas is high because this is higher now, right? So this gets higher to refine, and then the price appears at the pump, right? Think about it from the same perspective of orange juice and the hurricane. Same thing happens. So Back, I think in July or August, the President Biden released reserve supply. And when the Federal Reserve releases barrels, that releases more supply to be able to perform this process in storage. And that kind of went from 4 something to lower than 4. It's kind of been resting here at the moment. But again, we still are not producing, or we're not pumping oil out of Russia at all. I believe that our Saudi Arabian contracts are also non-existent. So that's the type of things that you're going to think about in this course. Let me go to the next slide. So just a little bit more about the petroleum supply chain. You have what's called an upstream. It's called exploration and production. Firms explore new hydrocarbon fields, discover fields, and get more fuel. And then you have midstream, and that gets it down to the pipelines through the terminals. And then you get the refinery and the refined process. So when you think about supply chain management, and I'm using gasoline, the gasoline oil industry as an example, it's a set of processes used to effectively and efficiently integrate suppliers, manufacturers, distribution centers, distributors, retailers, so that the products are produced and distributed at the right quantities to the right locations at the right time in order to minimize system-wide cost while achieving the customer's desired value proposition. So that statement alone includes a whole heck of a lot of integration between, in the oil and gas, exploration and production, midstream, downstream, all of that integration. And then you start introducing third-party suppliers. So just because you get your gas at a BP doesn't mean that that gasoline is from a BP refinery, because the gasoline is integrated with additive that makes it the BP gas. So gasoline's kind of like a commodity, right? So meaning that there's nothing really special about it. It's not, it's a general product, and then additive gets added to at certain terminals. But the supply chain process is the same, right? So let's look at how much more complex this gets. So as I said here, we got imported crude, domestic crude, imported from a ship, goes to the refinery, they produce the product, gets shipped to the refinery storage. It's through pipeline, right? Mostly through pipeline. Tanker or barge takes it to the bulk storage terminal, right? And then the tanker truck takes it to the gas station. So you see all of these intermediaries that come into play. So this has a cost. 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 So finally it gets to here, right? So let me tell you about a really interesting project I worked on. So I don't know if you're familiar with gasoline stations, but if you ever look at a gasoline station, they have what over here that's a vent. Usually it's 2 or 3 pipes, depending on how many tanks they have in the ground. And this is the tank that's in the ground, right? So the fuel comes in, and when the delivery truck comes in, the fuel goes in, the vapor goes out. So this is called vapor recovery. This was implemented in the 90s by the EPA to make sure that the air is safe, right? So as you can see, this is a certain size tank, and the fuel delivery goes into the actual from the tanker truck to the tank. In those tanks, there's something called an automated probe for automated tank gauging. So basically, it's usually by Veeder-Root is the predominant supplier of this. And it's a little gauge that tells you the volume in the tank, how much the tank will hold, how much you can fill it, and if there's any water or if there's anything specifically wrong with the gasoline. So it's pretty standard in the industry to have this, okay? So when you go to make a delivery, and let's say there's 3,000 gallons and the tank holds 15, and you have a 9,000 gallon truck, it can definitely fit. So those are some of the things that supply chain people in the fuel delivery capacity have to understand. Before they make the delivery, they need to know how much product is in that tank, right? So one of the projects that I worked on was La Palma, California. And at the time, we had bought Arco. BP had bought Arco, and it was about a year later, and we were implementing a supply chain system known as SAP, which is an ERP system, which I'm sure most of you are familiar with, an enterprise resource system that, in essence, helps you manage order to cash. So Arco had its own scheduling system, and BP wanted to integrate Arco and Amico. So we did the BP side, that was pretty simple. We did the Amico side. They were in Tampa, Florida, which was pretty simple as well. When we got to Arco, it was not so simple. The reason was because they had previously implemented this scheduling software and it failed. And so what I mean by that, it was colossal failure. There were runouts all over the city of Los Angeles. It was bad. And customers were complaining. I mean, imagine going to your local gas station and then being out of gas. Oh, that's not a good thing. So runouts all over the city. And so they were pretty resistant to any changes to their supply chain for good reason. And BP wanted it to be consistent across the United States. So I was the project manager in charge of this. And it was a critical implementation before SAP. So basically it was a fuel scheduling software that looked at heuristic algorithms to see when the tank needed the delivery through that Veeder-Root automated tank gauging system. So the challenge for me was to try to politically and correctly show them that this would be more successful than what they were doing by hand. So in essence, after that colossal failure, which was about 5 years before this time frame, they had schedulers doing everything by hand. They had all the dealers and the franchisees and the store managers calling in their inventories manually. And then they would schedule the particular fuel deliveries manually. Everything was manual. So I thought to myself, okay, so how am I going to lift these manual processes and prove to them that what we do, with this system, and it was incumbent upon me to get this approved before the SAP implementation. So I said to one of my teammates that I was working with, and she was the manager of the scheduling center, I said, hey, let's do a pilot. Let's test an area. Give me an area, let me test it. She's like, that's a great idea. So I got approval for Colton, California. And I think it was like 30 some stores. So it wasn't really a lot of stores. So that means that they were less worried about it in case there was something that happened. They had a backup plan to go back to pen and paper. And so I got approval to install the Veeder-Root technology. I came to find that it was non-existent, which was probably one of the reasons why the system failed. So when you look at risks and rewards, that would be the biggest thing that they made. The mistake was that this was non-existent. There was no way to tap into the tank to get the readings. In essence, they were getting them by hand and typing them in. So what we did, my team created a separate system for Colton, and we proved that we were able to minimize runouts by less than 0.02%, and performance was better than what they were doing by hand. So how do we do that? What I found, let me start here. I'll start over here first. While we were working on this, I started doing an analysis of just those 30 some stores. And after a review, I found that their tank capacities were much larger than any other area that we serviced on the East Coast. So meaning that tank that is in the station was at least 2 or 3 times larger than, say, the Pittsburgh area. So the Pittsburgh area, which we had been running, we started out with Cleveland first, which was the scheduling center for the Pittsburgh area. Average tank size here was like 10,000 gallons, and we were running efficiently. I found that La Palma's tank size was 40 to 50,000 gallons, and a gallon of gas in a tanker truck is 9. So the error is minimized. And then it dawned on me, that's how they're doing this by hand, because they have so much latitude to make an error. So once we figured that out, we showed that the pilot was better than hand scheduling. We minimized the need for 2 schedulers, saved on labor costs, and phone inventories where we moved so nobody had to be on the phone. And then SAP ultimately was implemented. So when you look at, in this particular case, in this particular supply chain problem, what I found was, here's a photo of a tanker truck, right? So what I found was they're 9,000 gallons, federal law for the United States, it has to be 80,000 pound gross weight. So with the tank and the product, it has to be 80,000 pounds or less. So some tankers are smaller, some can be larger, but normally they're 9,000 gallons in capacity. So, and as I said, the tanks at ARCO were 40 to 50,000 gallons. So they were huge fuel tanks, okay? So their tanks in the ground were 3-4 times larger than any other area we've ever worked on. So 20,000 to 40,000 gallons, sometimes 50. We were delivering and had already implemented New York, which had 4,000 gallons, and running it efficiently. So, and if anybody's thinking as they're watching through this, the 4,000 gallon tanks, you would split the truck. So the truck has compartments. And so half of the delivery, 2 of the compartments, normally they come with 4 compartments, 2 would go to, station 1, and then 2 would go to the other station, or perhaps even 3 drops, right? So, and compartments in the tanker truck is designed so that regular gasoline is separate from super gasoline, is separate from diesel, right? So in this case, for the West Coast scheduling area, the implementation of this system would improve the cost to serve, provide higher reliability and customer satisfaction. So it was a win-win for everybody involved. So this course is going to talk about 21st century supply chains and looking at supply chain management in the overall view, which I gave you the overall view of a gasoline supply chain. Implementing and looking at certain type of logistical processes, learning how to maximize supply chains globally, and thinking about companies that operate from a global perspective, and then lastly, the digitization of the supply chain and the digitization of the ecosystems that are going on in the world. Everything is about, increasing technology. So we'll dip into some of that as well. So I hope that this introductory video gives you some insight into what parts of this course is going to look at. You're going to actually study a case based on olives, which is a pretty simple process, kind of like gasoline. And then you're going to go into, depicting what a supply chain is for the olive. And then you're going to look at some numbers and how to work this out. And then you're going to write up a case to the investors. So I think that with the videos and the introductory videos and what Dr. Seelick covers and what I cover, you'll come out of this course with a very good knowledge of supply chain and 21st century supply chain. So welcome to 6510. Thank you for listening to me.